This is the first lecture on chapter 6, which discusses the normal distribution. So we have just finished binomial distribution. Now we're moving on to normal distribution. Normal distribution, unlike a binomial distribution, is a continuous distribution. So what we have is we do not have histograms anymore. We do not have distinct bars, and there is infinitely many things between 3 and 4. So what we do is we connect it with a smooth curve. There is no separate vocabulary list for chapter 6. All of the vocabulary is going to be discussed within the lecture. So this is the bell-shaped curve that I'm interested in. This is called normal distribution. Notice the name of a section is normal distributions, as in I will talk about two different names. This one is called normal distribution because it has a general mean. I will label it as a parameter mu. And it has standard deviations. Now, from the empirical rule, I actually know that if you move one standard deviation away, you will cover 68%. If you move 2 standard deviations away, you're now at 95%. And if you move 3 standard deviations away, you will now be at 99.7% of the data set. So this is your empirical rule. You cannot use empirical rule for non-normal distributions. So what we do is we greatly cover this in chapter 6. The other normal distribution that I want to make a note is called standard normal distribution. Now, they all look exactly the same. The difference between a standard normal distribution versus normal distribution is the mu is fixed at 0, and standard deviation is fixed at 1. So what you see is you have an x-axis that has very distinct labeling, and this standard normal curve is used to standardize the distributions, and it is usually labeled as a z-score. So looking at z's, looking at the z-score is really finding the number of standard deviations you are away from the mean. So we use the standard normal distribution in order to talk about the other normal distributions. Now, this squiggly line is actually a function. So those of you who remember functions from an algebra class, and those of you who studied calculus, will actually find this interesting, because this particular function can be described by this formula. Now, you don't need to use this formula. This is just something interesting for people who study calculus. And again, this is a distribution. So one of the things that we're going to be interested in finding is the area under the graph. So all of this area under any normal distribution, just like all of the other distributions, it has to add up to a 1. So this is only for calculus people, but if you can make sense of this, that's great. So what you're doing is you're finding the area under the curve, all of this stuff, and apparently it has to equal to a 1. Now, for the people who haven't taken calculus, this is a really funny looking area problem, and there's 2 ways to go about solving this particular area problem. One is the way the book represents it is using a z-table. Now, the second one is a calculator. The z-table is actually programmed into your calculator under all of the normal distribution buttons. So what we will do is we'll try to find a virtual z-table in our calculator and use our calculators. So there's no calculus involved unless you really, really want some. So my next thing that I want to, my next example is example 6-1, which is actually working with the standard normal curve. What we're looking for is the area under the standard normal distribution to the left of z is equal to 1.73. So I'm looking at example 6-1, and I have my curve. So I will make sense of the pictures in this lecture and show you how to do this on a calculator in the next lecture. Somewhere in the middle is the 0, that's my mu. They are asking to the left of z is equal to 1.73. So 1.73 should be a bit to the right of 0. And what we're looking for is we're looking for this area to the left. Notice on the far left, I always have a negative infinity. On the far right, I have a positive infinity. So what we need to do is we need to enter this into calculator. I will draw up a few other examples and then we'll go back and do this on a calculator. Example 6-2 is asking to find the area under the standard normal curve to the right of z is equal to negative 1.24. So I have my normal curve. This is my standard normal distribution. Therefore, the 0 is in the middle. Negative 1.24, that's my z. And I need to the right. And example 6-3 is looking for the area under the standard normal distribution curve between z is equal to 1.62 and z is equal to negative 1.35. So the same thing, I have a standard normal distribution. That means that the mu in the middle is 0. And they gave us 2 z's. One of them is negative, it's to the left, negative 1.35. The other one is positive 1.62. And I need for the area in the middle. Okay, after putting this into a calculator, the numbers that we are going to expect is 0.9582 for example 6-1. The numbers to expect for 6-2 is 0.8925, and the number for 6-3 is 0.8589. So all of the answers in the book are going to be correct to 4 significant digits because that's how the table is correct too. On the next video, I will show you how to put example 6-1, 6-2, and 6-3 into your calculator.